Hello. In today's video, we're going to be looking into infrared spectroscopy, and we're going to learn how to use a data sheet to identify the particular bonds in an organic compound along with the functional groups, and also to find out whether the sample is impure or not. Before we delve deeper into infrared spectroscopy, we need to understand the meaning of the term electromagnetic spectrum. White light is a part of a wider spectrum that's called electromagnetic spectrum. So electromagnetic spectrum looks like this. So you've got a wide range of radiation within that, and the light that we see falls under a very small wavelength range which is not absorbed by the atmosphere. So you see the rainbow colors there. A majority of the electromagnetic spectrum is not visible, but the impact of those rays is it's tangible. So when you sit near fire or when you're in the sun, your skin will absorb infrared waves and you feel warm. There is UV light in the electromagnetic spectrum, and that can cause darkening. The food in the microwave will absorb microwave radiation and it will warm up. So different types of radiation cause different things to happen in a compound. So using UV or visible radiation, the electrons transition between the energy shells. Same way infrared radiation is used and absorbed by the molecules, and it causes the bonds within the molecule to vibrate. Microwave works in rotating the bonds. Radio waves cause the nuclear spin to change, and each of these result in a particular type of spectroscopy which you'll study later on within the A-level syllabus. So today we're just going to focus on infrared radiation, and we're going to see what happens when a molecule absorbs infrared rays. So what is infrared spectroscopy? Is you'll always have an infrared source. So within the spectrometer, there's a source and there is a detector. So the source would be providing the infrared radiation, and if you just transmit the infrared source and it's collected at the detector, then the detector will identify all the wavelength within that particular infrared source. However, if you place a sample in between, the sample contains molecules, the molecules will contain bonds, and the bonds will absorb a characteristic wavelength from that infrared radiation source. Because that radiation wavelength is now absorbed, that will be missing amongst the light or the radiation that is at the detector. So parts of that wavelength from the source will be missing, and by using the output from the detector, we can identify which sections of that radiation is missing, and based on that data we can identify which bonds were there in the sample that had absorbed the missing parts of the radiation. So infrared spectrum is produced by the detector, and it looks like this. So on the x-axis is the wave number. Wave number is literally 1 divided by the wavelength. So that's your wave number. And when you look at the unit, so 1 over the unit is centimeter. So the overall unit is centimeter inverse. Higher the wavelength, higher the wave number, more would be the energy of the wave. Now infrared, on the right, on the vertical axis, you've got transmittance. So how much of that infrared radiation has transmitted, or it has gone past the sample. So you can see that parts of the spectrum indicates that there is 100% or nearly 100% transmittance. Some parts of the radiation has been absorbed, and that is your absorbance, and it's this part of the spectrum that is missing. So that has been absorbed by the sample. So infrared light is absorbed within this range, and generally all the spectrum will fall between 400 to 4000. Now it's very important to note this reading here. Any data that you see above 1500 wave number, this part of the spectrum is mainly used to detect the functional groups or the bonds within the molecule, and below 1500 wave number is used for fingerprinting. Fingerprinting region is below 1500, and this part of the spectrum is characteristic of a compound. So it's just like a fingerprint is characteristic of an individual. The fingerprint region of the spectrum is characteristic of a compound. So if you look at the data book, or if you've got a database of all the infrared spectrum, you can match the fingerprint area to the infrared of that particular unknown sample, and you can check it. We can also use that area to check the purity of the sample. So if the sample is pure, you will get the exact fingerprint in that infrared spectrum. However, if it is impure, you will get some other peaks here as well due to the impurity that's present in the sample. When you look at the functional group part of the spectrum, and functional group is this area above 1500 wave number, these are some of the key functional groups that are commonly asked at A-level syllabus. So OH with the alcohol falls within this area. So you would need to be able to identify from the spectrum these key functional groups. So overall in your exam, a data sheet is given. So you would, rather than being given this diagram, you would have to utilize the data sheet and say, okay, CH bond will fall within this area, OH in an acid, OH in an alcohol. They both are different wave numbers. So you would have to decode the infrared spectrum by using the infrared absorption data that's usually provided in the data sheet along with your question paper. So let's try out doing some examples here. So I've got the data sheet here. That's the infrared spectrum of an unknown compound. Now I will not be able to identify the exact name of this compound, because for that you would have to use mass spectroscopy data and also rely on chemical analysis. So it's a combination of techniques that will result in identification of the exact compound. But from here, we can see the data and we can figure out, looking at the data sheet here, which functional group is present. So if I look at this below 1500 area, that's the fingerprint area. So I would say ignore anything that's here. On this part is your functional group analysis section. In this section, I can see a peak here, and this peak is due to something. Then I've got a little bit peak here. So if I drop it down, so that falls under C double bond C. So C double bond C area, it comes under. So this indicates that that is a C double bond C. This big area is CH bond, and that you would find in most organic hydrocarbons. So this overall, I can say that this is an alkene because it has got a double bond within it. In this particular compound, again, I'm gonna ignore this section because that's the fingerprint area. Now I have got nothing here. I've got two big peaks here. This particular peak is the same as before. I have got CH, which is in 2850 to 3300. Then I've got the peak here, which is over 3000. So over 3000, the peak lies in the OH for alcohol. So that is OH for alcohol. So I know this is a functional group for alcoholic compounds. So if I have to do a chemical analysis, I could do a test on the functional group of alcohol and find out whether it's primary or secondary. So I can do the potassium chromate, potassium dichromate test, oxidation, orange color turning into green, or then if it's a secondary alcohol, I could do further testing once I get the oxidation product. Example 3, again, I'm going to ignore any data above 1500 because I don't need that. So you ignore this. Now we focus on this particular area. This is again, I've got here CH. So that's your CH. This one here is again OH. So I've got two spectrum here. Both are of alcohols, but we will not be able to identify the exact alcohol. If you look at, I'm going back and forth between example 2 and 3, they both differ in the fingerprint region, and that's why you will not be able to identify the exact identity of that compound unless you look at the database for the fingerprint comparison. So all you can do is say it's the functional group is OH. In this example, again, ignore any area in this side, so that's ignore. Now when I come to this side, so that's 1600, 1700. So from 1700, the data that I've got is for C double bond O. So I know that is for C double bond O, that's carbonyl compound. Now I've got a very big peak here. If you think about it, that's two peaks merged up here. So I've got here a peak for CH and a peak for OH here. So I've got peak for CH and a wide peak for OH. So that is my carboxylic acid group. So I've got OH along with C double bond O. So that indicates this is a functional group COOH. And you could do a chemical test. You could add bicarbonate to see effervescence, and that will indicate it is a carboxylic acid. Another example here, again, ignore over 1500. You've got 1600, 1700, another C double bond O. There is some CH peak here. Again, this is an example because of there is no OH peak. So that indicates this is either a ketone or an aldehyde. So it could be either. I cannot detect, I cannot say for sure which one is which unless I do a Tollens test or a Fehling solution test. This one here again, 15, 16, 17. So C double bond O, indicating it is a ketonic group. I can see a CH bond here. Again, it could be a ketone or an aldehyde. Again, you would have to do a chemical test to identify whether it's ketone or aldehyde. Aldehydes will give you the test, will give you silver mirror test, or if they will turn from blue to red precipitate with a Fehling solution test. So you'll have to do chemical analysis to identify the compound or the nature of the compound in this particular case. So overall, what we've looked into is that the infrared is absorbed in the region 400 to 400 wave numbers. We only use the region that's above 1500 wave number to identify functional groups. Below 1500 wave number, you will ignore it for fingerprinting, but if you've got access to the database, you can compare the fingerprints for different compounds to identify the nature of the compound. And analysis is done using datasheet. So please, if you like the video, don't forget to like it and do subscribe to the channel so that you get regular updates. And I will be posting some exam practice questions on infrared and also another one on the different mass spectroscopy techniques that's new to A-level syllabus, especially time of flight calculations. So thank you for watching.